and it works. Thank you very much. So let's go to the topic. So, okay, it's working. So a little bit of background. Before I founded the current company, Salvirt, 7 years ago, I was working with Microsoft for 14 years. And my last job was Sales Excellence Manager for multi-country region within Microsoft. So what does it mean? It was that one of my responsibilities was that I was responsible for a revenue of certain group of countries from Kazakhstan, then Baltic countries, then smaller countries in this region, then all ex-Balkans, and here Cyprus and Malta. And what does it mean in practice is that every month we had these internal live meetings where we were discussing with countries. So what's your forecast? Are you sure are you going to do it? Why are you sure? Well, we are sure this is going to happen. And then I would say, well, I'm not so sure. And then they would say, Marko, don't worry, it's going to happen. And then I would be looking at the colleagues, all smart people in my room. What do I think? They were like, oh my God, it's going again, so it's not going to happen. But what could you do? You cannot overrule the country because they know their business. See? And that was like a month after month. So the pain was for me higher or deeper, whatever you prefer. And then I was starting thinking, so in medicine, machine learning is doing miracle even 10 years ago, because there was like breast cancer case studies, things like this. So the question was really, what can we do with machine learning in the field of business-to-business sales forecasting? And that's my motivation coming from the business for very specific business situations which I was daily responsible for. And the situation is actually described nicely by this short sentence that we were actually all experiencing information overload, but knowledge starvation. So all that we have everything, but we just don't know anything. And the famous citation from Eng and Liu from 2000. So how we did it? After I went out to Microsoft, I was searching for mentors. Then with one mentor from University of Informatics, Professor Shikonia, we've kind of tackled the technical part very much easily, but then I was more ambitious. I didn't want to have this solution which will tell the forecast instead of people, but I would like these smart people here to learn something. So we've kind of construct this high-level picture of the research. So we have these B2B sales experts, when they have the CRM system, and based on that we would build different classification machine learning models, watch how they perform, which one is better, which one is more, I would say, closer to people in terms of acceptability or maybe prior knowledge, or maybe just measure the performance with, let's say, confusion metrics, or do the ROC analysis. So based on that, the key ambition here is actually merging the University of Organizational Sciences, where they deal how organizations learn, and computer science, because what we put into the center of our research is actually explanations of our forecasts. And why is this needed? Because when somebody from, let's say, Croatia would say, Marko, don't worry, this is going to happen, I would say, well, you're selling solution B, it's red. Are you sure? How you can be so sure in your statement it's going to happen, because the data does not support it? And then next month they understand, well, we cannot tell anymore Marko is going to work, we need to figure out something else, otherwise we are just saying, well, it's not going to happen now, maybe in a half a year. So this way we kind of create the bring data, like commander data from the Star Treks. When he was asked for opinion, he would always give or prefer the honest feedback based on data, not biased with human expectations. And then here, we still have humans for making decisions. And then we look this back, we have new insights, people are learning, then organization eventually gets better on forecasting. During these PhD studies, which I completed 2 years ago, quite a lot of the research papers were published. The most prominent was here, in terms of the scientific citation, is expert systems with applications. And just recently, this year, Springer book, Springer in latest book, Machine and Human Learning, showcases our case as a way to help organizations to learn from the data. And also in Croatia, just 3 months or 4 months ago, Croatian Society of Operational Research published one of the research papers which is dealing with one of the sub-problems within that area. And also I have, just to make it commercially viable, I put it as a service, Sales MT, so salesnewtechnology.com, which you can today subscribe for 1 month trial and see how it's working in the practice. It's a scaled down version, I can explain it later if there are questions. So first, we want to be very efficient with the data assessment. So we've seen in many presentations today that the data is very important, and everybody says that acquisition of data is very important as well. Actually, in practice, I don't have the problem which is called big data problem. I have a problem which is called scarce data problem. There is no data. I mean, they are data in CRM, but when you put them into machine learning, models, they don't learn anything. It's close, classification accuracy is close to 0 to 0.5, which is close to the controlling. Why? Because the structure within the CRM is not focusing on the right fields, which are then applicable for the machine learning. So what does it picture say? This one? We take the business sales data set, and we calculate the distance between the cases. So the lighter, the better. And we see we have this diagonal, we have this black line, which means that which just proves that comps is working right, because those are comparing to same cases and it needs to be 0, so there is no difference between cases. Then we have some stripes here, which are showing us the lighter that they, from the sales perspective, they've done some activities, and they really went for the follow-up with the clients because the data in the cases are different. So with this, when you understand the logic, you need 2 seconds to understand what's the quality of your data set in terms of the differences. This black dot here just means that somebody who is pushed by manager, hey, you need to update your CRM, he will just copy in cases. When I present this picture, well, yes, I was pushed, I needed to do. But it's shown here and it's not really good for the machine learning processing. Now the next step was really assessing which model is working the best. So we've used random forest, naive-based, decision trees, SVM, support vector machines, and neural networks. And in classification accuracy and also in area under the curve, random forest was among the top. Most people understand this one, but we used also the AOC because we cannot claim that our data are distributed normally. And for that, AOC is much more precise measurement of the quality of the data than other metrics. So I've intentionally left here that support vector machine is working poorly. It's not really working poorly, but you need to have much more experience how to actually put the parameters into that to achieve comparable results. So it's easy for starters or for beginners to miss it. It's a good method, but here when you're comparing different models, you need to be cautious about Do you really can trust this data? So then we've applied this model. This is simple toy model. What we have here, just for the illustration purpose, we have a data set where we collect 5 different features, whether the sales is complex, whether who is seller, do we sell to existing client, which solution we are offering to the client, and what is the authority of the person we are talking at the client side. And for example, authority, if I take low, means somebody is just gathering the information, it has no impact within the buyer organization to purchase. Somebody who is high is actually the boss signing the contract and saying, yes, we have budget for that. And mid is somebody who is doing, he has the, let's say, responsibility from the project side, but he needs to ask for the money. And just to give you the explanation of that, and that's critical in practice. You need to have workshops to explain over and over what does these labels mean, because they tend to need more iterations to then use it correctly in the practice. So if we are just taking one, let's say existing client, we have here the blue side, so good side, and the red side, the bad side. It just shows graphically how much this attribute contributes to the positive outcome of the sales, and also here how much contributes to the negative outcome of the sales. For example, if we are selling to existing client, which is yes, then it looks like it's much more probable that we are going to win the deal. But it's still some level of cases or probability, which means that we are not getting the deal or that we are selling to the existing client. While if we are taking the, let's say, view with no, it's slightly more, has tension to not winning the deal, but of course, we always need new clients, so we need to win some, so we have some portion here as well. And what does it mean now in practice on a specific case, because this is model view, we have a specific case where the complexity of sale was moderate, the seller account manager was selling to existing client, solution B, and he was talking with the authority mid. And this deal was won, and the output to be won was 82 points. And now we can see the most important element of this story here was the fact that this is the existing client, and then the seller was AM, and then the authority was mid, and then the complexity was moderate. The fact that we were selling solution B, which is new solution, which we are just adding to our portfolio, was negative, but was not prevailing. Why is this useful? When you have this meeting, everybody has his own mental picture of what works in sales. And then somebody will say, well, it's all about seller. Then people are saying, no, it's all about whom you're talking about. You need to talk to top manager and then you're going to sign the deal. Well, with this, you at least can challenge them. Data does not support these mental models, and then start upgrading their mental models, which is the behind the scene my idea, organizational learning. So when you have then sales meetings, then you are having the discussion. So what is going to happen next? So what does it really make sense for me as a seller to work on? And here we have the real world case study, and we are going to do what if analysis. Currently, this output to be closed is 41. So the seller goes to a meeting, and then he said, well, I was talking to them, client said, okay, we didn't know budget confirmation earlier. Client now would say, yes, we have budget. And then we were also talking about partnership with this specific deal. And yes, we are now have the agreement to go for the opportunity with partners. And now probability just went up to 49. So this is kind of what-if analysis. What makes sense for me to work? And before managers make decisions, they can also play, and they do. If I change salesperson, what does it mean? Things like this, and then from that perspective you have a more educated guess about the next steps. 5 minutes? Okay. So, this is now ready. The studies were completed for 2 years, and the last 2 years I was really focusing on putting that into life for people to use it. I have to say, this graphical explanation is overkiller for people. So, for the moment, it's not yet available on salesnt.com, but can be easily added. It is added for some clients, but they require the training. So what we do now, if you go for this site, you register and then you put your opportunity, and then you can do it as well. It's going to work immediately. Then you have your opportunities ranked by the maturity score, win propensity. When you have this picture, then you can have a view table below. So what does it really make sense for me to focus to close the deal? And for example, I would say, okay, demo, food store, it's upsell, yes, well, but this is not realistically, this is, well, it's not realistic, I'm not going to go after that, but then let's say the big bank, when the competition currently is value is unknown, if we achieve with sales activity, that they tell us, hey, you don't have competition, but be smart in putting the offer together. So we have no, and this gives us 19.7 point up in our probability win propensity score. So as a seller, I go for easy fruits. So with least effort, I have a more outcome. And then there are, let's say, other attributes like buying motivation. When the seller needs to understand why is really customer buying that, that's not really a question. It's really not really a question. And if he can confirm or she can confirm it's clear to him, then in this case would bring 2.8 points. So based on that, we can group all the opportunities for the rest of the month. So we have low, mid, and high, and this is what we are interested to. And then when we put that into the current performance, so we have these opportunities, and then we say, yes, they were won, they go into these charts. So in orange we have plan year to date, in blue we have achievements year to date, and then in green we just add those numbers when the machine learning models would say this is highly closable and you can realistically count to that, then it's added to the graph so you can see based on your other targets, monthly plans and so on, how you are going to finish the year. So here you're going to be above the plans for the full year. So with that I would conclude. Please visit site, please use it, try it. If there is any question, you can write me email to salvirt.com, and I open for questions.
Thank you. Any question from Mr. Bohanec?
Questions, please. Tough questions, please. I hear you, you can tell me.
Why did the XVM model have such a big variance in the box plot diagram?
It was used out of the box without parameterization. When we had more time to focus on SVM, then we applied the grid search, which is automatical way of that, and then it was performing much closer to others, but still not being the best.
But other models you did proper research and found the best parameters.
For others was, let's say for the most random forest, we've done the balancing between 200, 350, 400, so trees, because you put it there, and this one we were quite sure, and there was no huge impact on such a variation, yes. Yes. By the way, the explanation model works on irrespectively which model you take as a machine learning model. So that's a huge benefit. So you can one day use, as a business user, one day I use random forest, I don't know, because the new data causes the naive base works better. Then next day I see the same picture, but behind is naive base today. See? That's the beauty of that model developed by Professor Shikonia. There was more questions there.
Very nice presentation.
How do you fit data into this problem?
So currently like in blockchain, I have a genesis block. See, so the block which you start, which is actually in the public domain, because one of the issues with business to business is that there is no data set. So during the research, I gave one into public domain, and every day somebody, 3-4 people today was from India and from Belgium already downloads that, and then they do what they do with that for further research. Another is to take from CRM. We don't do that, but after we make the prediction power assessment. So if you want to be my client with your data, you need to have the classification accuracy at least 70%, which is the minimum standard for social sciences. If we are not achieving that, that's no go. Then this model is not delivering on the promise, and the minimum standard is 0.7. And there is a third way, would be upload with Excel, but that's manual work. But we can do it. Thank you. Good question.
Okay, thank you a lot.
Okay, thank you.